Okay, so we're going to look at some of the graphs of this. Now, if I look at this one graph here, could you even come up with a basis of what this looks like in a factored form? So at this point, we should be able to do that. Now, if I'm looking at this here, I'm looking at my x-intercepts. So I see it crosses at -2, -4, and +1. So I would want those in there. And so I'd have to have factors. And really, we're looking for we're looking at the factor that where -4 makes that 0. So it's going to change that sign. So we're going to see an x plus 4, an x plus 2, and an x minus 1. If I pull that out, it's exactly what I had graphed. So let's look to see if something's happened. If I put a negative in front of this, what do you think would happen with the graph? So if you notice that the x-intercept stayed the same, I'm still at -4, -2, and 1. But all of a sudden it flipped. Okay, so what was up is now down. What if I put a power on one of these factors? So I'm going to put it on the x minus 1. So we should really pay attention because that's where our +1 x-intercept came from. So let's see what, let's focus on that +1 and let's see what happens when I put a square in there. Okay, so see how we have all the same points, but there's something that looks a little bit different at that +1. Let's put a square in another one too. So I'm going to put it at this x plus 2. So let's focus at the -2. Can you predict what might happen here? Okay, we see that. Okay, we see, again, both of these really have that maximum or that turning point right at the x-axis. Now, I'll tell you this, that sometimes it's going to be a minimum as well. So even like if I take out this negative over here, okay, now they're going to be minimum points. But we could even have one of each. Let's see if I take this square away here. And what if I put a square here? So I do have one max and one min in there too. Just a matter of how it flows. Right. Let me take away these and go back to our original function here. Okay, well, what if I put a number out in front, like 3? Okay. Our x-intercepts didn't change at all. Just our min and maxes did change. Actually, all the other points really changed too. Stretched it. It was a vertical stretch. Okay, so we do see sometimes like those numbers out in front do affect it. Now, if I put an x there, it creates another x-intercept. Okay, and so that creates it right at 0. So having another x value in there does create something different. And even like when we're squaring, we're really kind of adding another x in there as well. So let's look to see how this relates to our graphs here. And we have 3 that are in factored form. And first of all, we're going to look to see, are these completely factored? So in the first one, in the parentheses, I'm looking for greatest common factor or difference of squares, and I don't have anything like that. So it's completely factored. The second one in the parentheses, again, nothing I can factor more. The third one, this one can factor more. So let's just rewrite this. We have x, or 5, and then x plus 2 squared. And this is going to split, so this is a perfect difference of perfect squares. It's going to split into x plus 3 and x minus 3. Now that's going to help us to find out all our zeros, which are our x-intercepts. So first, let's start off by finding our zeros of our function here. And really, we do that by setting our factors equal to 0. So we're going to set 3x equal to 0. We're looking for when our function equals 0, our y values equal 0. I divide by 3, I get still 0. X minus 1, I set that equal to 0. I add 1, and I get 1. X plus 5 equals 0. I subtract 5, and so I get -5. So that's really the reason why those signs are changing, is because we're solving for x in these little mini equations. So I'm going to mark these points because these are our x-intercepts. Okay, let me find it for the next one. So if I set this negative x squared equal to 0, I divide by -1, I still have x squared equals 0. I square root, I still have x equals 0. Next one, x plus 1 equals 0. I subtract 1, so I get a -1. So 0 and -1. And then the last one, I set 5 equal to 0. That doesn't give me anything. X plus 2, I really have this twice, but I can solve it just once here. So at negative 2. And then x plus 3 equals 0, so I subtract the 3, and I get negative 3. And then x minus 3, I add 3, and so I get a positive 3. So those are all my x-intercepts that I have for each one of these functions. Okay, so now we're going to see how we can graph these and the flow through it. So we saw that when we had a square, we had this bounce that occurred on the x-axis. So I'm going to mark that bounce here. I'm going to circle any points that have a bounce. So the first one, I don't have any of those factors squared. The second one, I have this first one, this negative x squared. That's what's from 0. So this right here is a bounce. So I'm going to just circle it when I do this, but I'm going to label it right now to define that this is going to have a bounce right there. And then the last one here, I have that x squared. That squared with the x plus 2, so at this negative 2, this is going to have a bounce. So either a minimum or maximum point right there. All the other ones is going to pass right through those points. Okay, and then we were seeing too that sometimes that there was a negative out in front and it made it go up or down. And so what we really want to focus on here is that to see if we have a negative or positive leading coefficient. Now sometimes they can be a little tricky here, but we have just in the parentheses, it's a positive x every time. So we were really looking at this value out here. This is positive, so it's going to end positively here. Out here, this is negative, so it's going to end negative down here. So just putting a dot where it's going to go. And here, this is positive, and so it's going to end positive over here. So there is a way that we could also look at the degree, but if I just take this knowing where it ends, I'm going to backtrack through it. So the first one, I'm going to backtrack and go through this 1, through the 0, and through the negative 5. And this is what my function looks like. The next one, I'm going to start over here. I'm going to come up at 0. I'm going to bounce there, so I'm going to turn around, and then I'm going to come up and go through the negative 1. And the last one here, I'm going to start up here. I'm going to go through the 3. I'm going to come up, I'm going to bounce at negative 2, and then I'm going to go pass through at negative 3. So if I'm looking at that one extra part that you can also look at, the degree, I'm looking at really what my highest power would be if I multiply this all out, really kind of how many x's I have when I'm multiplying, because that power tells us how many x's. So in here I have this x times this x times this x. This would be a degree 3. This one I have an x squared times an x, and so that's going to create a 3. So my degree is 3 for that one as well. And for this last one, you can look at either one. But here, this x plus 2 squared, I have 2 of them there, and then this x squared, I have 2 of them there, so that's a total of 4 for that. So if you notice with these odd ones, the ends go opposite directions, and this even degree, the ends go the same direction, in this case, both up. So just summarizing here, this leading coefficient, okay, the way that this really affects the graph is if we look on how it ultimately ends on the right side. So determines the ending, so right side, whether it goes up or down. Okay, and then our multiplicity, so if we have factors multiple times, so if we have squareds, and we're really looking at an even squared on there, so factors multiple times seen with exponents on factors. What we're going to see here is we're going to see a bounce on the graph. So it bounces on the x-axis. Okay. All right, so those are the big things that we really have added here because we had our x-intercepts before, but we do have to make sure they're completely factored. And then we see just this, it's really our end behavior that we're seeing that's going on with this, and even this multiplicity is going to be that middle of what's going on. So we're going to put that all together in the next ones, but we do want to tie everything together so we can get a pretty good sketch going on here. But notice that we didn't really graph anything in the y-axis in that scale. We're looking more on